So today's very short. We're just talking about two concepts. The first is continuity, and the second is one-sided limits. So continuity is a word that you will see in calculus a little more, but I'm just going to introduce it briefly. A function is continuous if it doesn't have any holes or jumps. That's the simple definition. The more complicated definition involves limits, which I will just decline to explain to you. So just take this simple definition and that'll be good. So for example, this function here, f of x, based on the graph, is continuous on the interval a comma b, because there are no holes or jumps within that interval. Pretty simple. Any questions?
That's continuous function.
This function is continuous on the interval a comma b.
So if you did like a interval like a minus 1, b plus 1, it would not be continuous.
It would not be defined on that interval. So it's not a very meaningful statement, but sure. Anyways, any questions about this? Okay, let's talk about left and right-sided limits. So limits, as you guys remember from last class, in order for a limit to exist, it has to approach the same number from the left and right sides of A, right? However, we can also define left and right-sided limits, where we only care about what value the function approaches as we're approaching the number from either the left side or the right side. So in particular, a left-sided limit, the notation is that instead of writing x arrow a, we write x arrow then a, and then we write a tiny minus sign to the top right of the number. Okay? It's kind of like a exponent almost. And that's just indicating that instead of approaching a from both sides, we're only considering the limit as a is being approached from the negative side or the left side. That's why it's a minus sign. In similar fashion, if we have a plus to the top right of the a, then that means we're approaching it from the right side, positive side. So for example, in the function that I've drawn here, there are going to be two different limits depending on whether we're approaching from the left or the right. If we're approaching from the left, we get a smaller number. If we approach from the right, we get a bigger number. So what we learned last class can be now formalized in this statement that the limit of f of x as x approaches a only exists if the left and right-sided limits are equal to each other, which tells us that the function is approaching the same value as we approach a from both sides. Okay, if they're not equal to each other, then we can say that the limit does not exist. So frequently, for a function, the left and right-sided limits will exist, whereas the actual limit itself does not exist. It's pretty common. Any questions? Okay, here's another example. For this function here, the left-sided limit is 2, the right-sided limit is 4, but the limit itself does not exist because 2 does not equal 4. Thus concludes my lecture.